Hey guys, this is CHEMPLIFIED and today we will take down the new topic, the gas laws. In the gas laws, we will talk about Boyle's law, Charles' law, lussac law and Avogadro law. These are the four laws today we will take a look into. And we will try to make a trick out of it to learn all the gas laws together. If not together, most probably these three, right? So let's start. All the gas laws mainly take into account the values of pressure, volume, and temperature, and number of moles in Avogadro law. We will first take a look at pressure, volume, and temperature relations which are present in Boyle's law, Charles' law, and Avogadro law. So, first we will try to make a trick out of it. Consider pressure, volume, and temperature and give them number 1, 2, 3. Now divide them into pairs 1, 2, 2, 3, 3, 1. First and second is pressure, volume, second and third is volume, temperature, and third and first is temperature and pressure. So this is your Boyle's law. This is your Charles law. And this is your lussac law. How can we say that? Because Boyle's law is the relation between pressure, volume, Charles law is the relation between volume, temperature, and lussac law is the relation between temperature and pressure. Now we can use a single statement to tackle all these three laws. So our statement will start with, for a fixed amount of gas, for a fixed amount of gas at constant. Now look at Boyle's law. Pressure is there, volume is there, but what is not there? Temperature is not there in Boyle's law, right? So if temperature is not present, that means it is constant in Boyle's law. We are talking about Boyle's law right now. Okay? For a fixed amount of gas at constant temperature, right? Now you have to write the relation between pressure and volume. Pressure is inversely proportional to volume. This is your Boyle's law, right? Now move to Charles' law. The same statement will take down every single law. For Charles' law, temperature is there, right? The statement will change in the end only. The relation and the constant value. So for Charles' law, what is not there? For Charles' law, pressure is not there. So for a fixed amount of gas at constant pressure, volume is directly proportional to temperature. That is, V is directly proportional to temperature. This is your Charles law, right? Now with the same statement we will take down lussac law. Rub the end part, just the relation part. Now look carefully. Temperature is there, pressure is there. What is not there? Volume is not there. Right there also, temperature is not there. So volume is not there in lussac law. So for a fixed amount of gas at constant volume, what happens at constant volume? Temperature is directly proportional to directly proportional to pressure. That is, pressure is directly proportional to temperature. Either you can write this, or temperature is directly proportional to pressure. So with the single statement, you know how to write Boyle's law, Charles law and Lussac law. Just look carefully. When pressure and volume is there, temperature is not there, so temperature will remain constant. Volume and temperature is there in Charles law. Pressure will remain constant, and temperature and pressure is there, volume will remain constant. That's how you have to write the definitions and the relation for Boyle's law, Charles law and Lussac law. Now we will talk about Avogadro law. Avogadro law is the relation between number of moles and volume. Now, if you try to remember, Avogadro is very famous for 6.022 into 10 to the power 23. This is Avogadro number. It simply represents 1 mole. Right? You all are familiar with it. Now mole is there in the relation and something else is there, volume. Now number of moles simply represent number of particles present. Number of particles. So the law state for a fixed amount of gas, Avogadro law states that equal volume of all gases at same conditions of temperature and pressure contain equal number of molecules. This is the statement, and the relation is given by volume is directly proportional to number of moles. Now why volume is directly proportional to number of moles? Volume simply increases as the number of particle increases, and number of moles just represent the number of particles. So as the number of particles increases, the volume will also increase. If the pressure is not constant, if they are free to move, they are free to expand, then volume will definitely increase as the number of particle increases. So that's what is Avogadro law. This is the only one different from the other three, so you have to learn it separately. So today we discussed the 4 laws: Boyle's law, Charles law, Gay-Lussac law and Avogadro law, and these are the relations. Now if you look closely, only Boyle's law is the one where the relation is inversely proportional. All these three are directly proportional. So don't get confused. There is only one relation, that is Boyle's law, that is the relation between pressure and volume, and it is the only relation which is inversely proportional. All others are directly proportional. And these are the gas laws that will be used to create ideal gas equation, that is PV is equals to nRT. We will derive this equation using these laws in the next video. But before that, we will discuss them separately in the upcoming videos. This will be it for today's video. Thank you. Have a good day.